Tokyo. Cool. Ohio gozaimasu. I'm gonna kickstart this day with Semantic rocket fuel for your microapp. So I've been working on a new information modeling system, and I was looking for the right technology to use. And Bitcoin has some interesting cryptography elements, like we hash the data, we got public private key pairs, we got the time chain. So I was thinking about using blockchain technology, but yeah, it doesn't really scale so well, and yeah, I wasn't too happy with the approaches that was out there already. There's so many scams around. So I stumbled upon Nostr. And why Nostr? Well, it's nodes and other stuff transmitted to relays, and my information modeling system is definitely other stuff. There are force clients and relays already there, ready to use. There's an amazing community. That's you guys. Also, the timing was spot on because I was just looking for something like this. So, Nostr all the things. The agenda for today is that I'm going to present two new systems. The first system is for making things more human-readable, and the second system is for making things more machine-readable. So system one is a fairly simple system, and it is for making human-friendly descriptions. We live in a world of really large numbers, all the private keys, public keys, signatures, transactions, IDs, all those are just really big numbers, and they're not very human-readable. So to compensate for that, I figured a very simple node structure, which I call the descriptor node. And the descriptor node has 4 fields. It has a point, which is what we want to describe, or the descriptor, if you will. It has a name, which is basically a field meant for a human-readable name. It got a label, which is a short description, just a one-liner, and then the rest of the node is dedicated to a multi-line description called a description. And we can see we have an example of one up here, right, where there's a hash to begin with, or some kind of a hex value, which is kind of unreadable. And then we put in a human-readable form called, where we call it order number 1, 2, 3, 4, 5, and then we all of a sudden know, well, we have an identifier, we kind of know what it is. Then we put in a label where we call it web shop order of a t-shirt. Then we know that much. And then we have a multi-line description. This is awesome t-shirt in size large, order from web shop, order number 1, 2, 3, 4, 5. Remember to pack sticker freebies. And all of a sudden the number up there is quite approachable. And it would be kind of nice to have for many things we meet in cyberspace, like all the Nostr IDs we have right now, for example, from members we meet. All the fields except the point, of course, is mandatory, is optional, and yeah, that makes the thing much more general. So how do we implement this in Nostr? I'd like to use the old, good old developer principle: keep it simple, stupid. There's a lot of, I mean, when you do a new NIPS, then it's very tempting to just say, oh, I'm gonna put this into the JSON document, or I want to put this into the JSON document. And I feel like the JSON document is already pretty advanced. I mean, if you look at this, this is a typical Nostr node as it looks today, and it's not even advanced. We got the ID, we got the pub key, we got the timestamp, the signature, the actual content that we want to convey. And yeah, the tags are not even filled out on this one, and it already a lot. So I kind of hope that people won't pollute the simple Nostr message with more metadata. So instead, for the descriptor node, I simply introduce a new kind called 101, and then I dedicate in the content field a line to each field in the descriptor node. So line number 1 we just dedicate to the point, then line number 2 will be the name, line number 3 will be the label field, and the rest of the node will be the multi-line description. And with that, we have something that is fairly simple to parse and doesn't really pollute the node, because everything is pretty much in the content field where we will have our node anyways. So I like to demo that, and I have forked a nice little client called Gossip. It's made by a guy called Mike, and I think a few of his friends as well. It's quite slick. I like if you go into my notes, it has little features like this one. This is a little stake icon. If you click on it, then you can see the actual Nostr message as it looks and get the Nostr ID and so on. Kind of like that. Next to it, I have made my own little icon called Diskit. And if you click on disk, then it pre-outfills the point with the ID of our Nostr node, and then we can say, well, here's a little node where maybe we have reposted someone's node. Let's say call it Joe's message. If I can spell, let's call it Joe's message. And let's say it's Joe's favorite food recipe or something. Great. Then we click create, and now we have created a new node that then contains a description of this node. And so the trick here is that instead of putting it into metadata of the node itself, we actually generate other nodes that describes other nodes. And this means that in the future we can make quite advanced search features. Where sometime in the future, when we can't really remember what was Joe's favorite recipe, then we can just look it up on our nodes for the nodes themselves. So this was a very simple demo, and now we go on to the system 2, which is making things more machine-readable. So this is where it gets a little bit more complex. And this is for making micro apps, and it's also for making micro protocols, and it's for paving the way for more advanced AI stuff. And it is based on infographs, because infographs was basically made for this kind of project. So a short intro to the infograph. It was invented by some weird Scandinavian guy. It's a graph-like structure where edges can have edges, and each edge is an atomic bit of information. So this is a picture of a normie graph. This is not an infograph. This is what we are used to look at, right? We got Alice, we got Bob, and then everything about the relationship is on the edge itself. So in this case, Alice is friends with Bob, and that's in the edge. On the infograph, the edge is atomic. So we don't have anything on the edge. We just have Alice, and we got Bob, and then the edge between them. So there's actually 3 objects. Alice is object 1, Bob is object 2, and the edge itself is object 3. And we don't even have Alice and Bob. We just got ID 1, which is an Alice, ID 2, which is Bob, and ID 3, which is the graph, the edge itself. So how do we model Alice and Bob's friendship? Well, we have our relationship from Alice to Bob, and then we put an edge on the edge from the relationship between Alice and Bob to the concept of being friends. So in this picture, it looks like we have 3 edges, but we actually only have 2, one between Alice and Bob and one between friends and Alice and Bob. And to make it a little bit more readable, we put sometimes parentheses around ID3, as we can see here. So this a simple edge we also call an info triple, and it can be written in a tuple structure, so that we put ID3 first because that's the identifier, column 1, and then we put ID2, which would be Alice, and ID1 in column 2, which would be Alice, and ID2 in column 3, which would be Bob. And we can actually we can stack them on top of it, and on top of each other, and then we get an info table. So in this case, we could say, well, here we have ID1, ID3, ID1, ID2, so that would be Alice and Bob, and then underneath we can see ID5, which refers to ID3, and then have ID4, and so ID3 would be the relationship between Alice and Bob, and then ID4 would be the concept of being friends, and so on and so forth. We can basically, it's okay if you don't get it in the first run. It takes a time to wrap your head around it, but it's quite cool because you can actually model all information there is just by 3 IDs like this, and then make a long list. So how do we model that in cypherspace? Well, in cypherspace, all our IDs are hashes. So Alice would be a hash of something, and Bob would be a hash of something. And well, the natural way, if we then need to have a relationship between them, that we need a new hash, what would we do? Well, obviously we will take Alice and Bob's IDs and Merkle root them. And in that way, we can also verify that the Alice and Bob node hasn't changed in the future, because we just sort the 2 IDs of them, concatenate them, share 256 hash them, and then we have ID3 again. Well, it would be nice then to, if we then sign this data, then we also have a user that created the triple. So and we get that in Nostr for free. So how do we implement that on Nostr? And again, I use the principle of keeping it simple, stupid. I don't want to pollute the Nostr message with more metadata in the document. Again, here we have a typical Nostr node as it looks today. It's already filled out. So instead, I introduce a new kind called 211. And then in the content, we have an info table where each line represents an info triple. And yeah, so I would like to demo that now, and I think that's going to be quite interesting. So if we go back to my notes here, then next to the disk icon from before, then we have another little new icon called Tagit. And here we see ID1 is pre-outfilled with the ID of our node. And then we can select a value down here, so we can tag it as, let's say, this is awesome, for example, and say this, click create. And then we have an info triple, as mentioned before, where we have where we have tagged our message as being awesome. We could also tag it as being spam, for example, and then click create. And now we have an info triple representing that. Now it's a bit of a mess that we both tag our message as being awesome and spam. So how do we cancel out that? Well, first we choose the thing that we want to cancel out. Maybe we say, okay, this wasn't really spam after all. So we click on the note. I don't know if you can see it here, but now we have the triple of the spam that we did before the spam tag. And then we say this one is cancelled. Click create, and now it's cancelled. Maybe I should, can you guys see it? I'm just gonna make it a little bit bigger here. And so you can see on the side we have cheated a little bit. There's a bit of syntactical sugar here where we actually put the message as a spam. This is awesome. You know, in the wild, this would be a hash as well. But we could also we could put more notes on our more text on our note from before. Let's see if we go back to our note here. Then we could tag it as this is. It was a food recipe, right? So we could take it as this is a food recipe. Just click create, And then we could put some text on the food recipe itself. So we choose the triple here, get it up in the box for ID1, and then we can say contains tomato, contains salt, contains, let's see, what do we got? Do we got olive oil somewhere? There. Contains olive oil. And with that, we can start making quite advanced taggings, and we can start making quite advanced micro apps, because now we can say, oh, we could make a food star app where we say, give me all the Nostr nodes that contains food recipes, and then it will find this node. And we could even say, okay, give me all I have tomatoes in my fridge, give me all the Nostr food recipes that contains tomato. And then we can set that. But there's a problem though, because we have all these hashes here. I mean, it's sugar-coated a bit with the tag names out here. Which should have been, which would be hashes as well. So how do we make this more human-readable? Well, we can use system 1 from before, the descriptor node, and then basically make use the descriptor node to make this more human-readable. I'm not going to stand here and make descriptor nodes for all of these, because it will take a while. So I have cheated a little bit and made this screen just for demo versions. First I made just reproduced the hashes that we had from before, just made it a little bit simpler. So now our hash is ID1. I don't know if you can see it. And then all our triples are from 2 to 8, and this is awesome would be tag number 100, spam 86, cancelled 0, this is a food recipe 700, and then all the ingredients 700, 1, 2, 3. And then I made a description for it. And so with a description, it would be something like this. We can read it, and we could say, I'm just going to put it a little bit bigger. The first triple we made was our awesome rating. It's the message from Joe. We said, this is awesome. Second triple, we said, again, this is a message from Joe. And we said, this is spam. And our third triple is our cancellation, where we said, this time it was our spam rating that we said this is cancelled. And then we took we made a triple called Joe's food recipe, which was a message from Joe that we said this is a food recipe. Then we took Joe's food recipe and added an ingredient to Joe's food recipe called contains tomatoes, added ingredients to Joe's food recipe contains salt, added ingredients to Joe's food recipe contains olive oil, and all of a sudden it's much more human-readable. And note, we have only used the label field of the descriptor node. We could also enhance it with a name or a longer description and make it even more readable. So this is all cool. This is good for people who, developers and people who want to play around with the infograph and make their own little data nodes. Of course, for the end user, we want to make it even more slick. So for the last view down here, I have made a couple of demo apps. I'll zoom in so that it's a little bit easier to see. It's very, very simple micro app prototypes, really. The first one here, we have something that looks like a feed. So where we have a nice little icon of a letter to indicate there's a new something new coming in. We have the actual text of the note, and then we have a rating where we have translated our "this is awesome" rating to 5 stars. And if we mouse over the little envelope, then we can see we get the ID of the message. If we mouse over the rating, then we get the idea of the rating itself, because that's two different things, and that means that we could, in principle, then dispute the rating and then change it around. As we extend this app to become an actual app. Underneath it, we have the recipe app, just a really prototype-ish demo of a Foodster app, where we have the recipe itself, and then it has listed all the ingredients, because it can read that we have the ingredients from the infographs. So we have a little icon for our tomatoes, and a little icon for our olives, and a little icon for our salt. And we can even get the IDs of these triples as well, meaning that we could, in principle, make our own little notes to that. Say the tomatoes, we have maybe a special kind of tomatoes that we find is good, then we can write a note for that. And then other people who read this Nostr note, they can get the recipe, but they can also get our added tips for what would be better if they like. And with that we can make all kinds of new applications without polluting the JSON document of the Nostr node with all kinds of metadata. We basically, for these two apps, we're basically using the same simple data format of the info triples. So yeah, that's the end of the demo, and it's actually also the end of my presentation. If you guys want to follow along, then I made a profile just for this startup from this conference. It has a QR code. We have you can also find it on iris.to/semantics. Funding is so very welcome, because I'm doing this in my own time for my own money. I would also like to appeal to people when using this to have some moral and ethics, because it's kind of powerful technologies that we are releasing here. And I'd like to end this presentation with my favorite quote of Halfin: "The computer can be used as a tool to liberate and protect people rather than to control them." Thank you for listening. Okay.
You happen to take questions?
Yeah, sure.
Have you thought about working through labeling?
Yes, and I might even use them to label the encoding of it. But the thing about the labels is that they are, they're nice and all, but they're made for Nostr. The thing about my system is that I didn't make it for Nostr originally. I actually made it for something completely different. And then I was like, well, I want to use private public key pairs to sort of verify the user that's making this, and then I bumped into Nostr and like, well, they're doing that already, so why not use that? But this is meant to be something you can then take out of Nostr, and then you still have then you don't need to pass the JSON files. But yeah, I'm aware of those. Yeah. Yeah. I'm not there yet, but that's going to be one of my my interesting. So he asked how about performance and data structures in if we're going to make bigger queries in the future, and that's going to be one of my interesting little side projects in next year, basically. Yeah. So, any more questions? All right, thank you.